In the third and the last part of the DMCSEE introduction, we will look beyond the region. So that means we will not be focused only on the drought monitoring system that exists specifically in the southeastern European region, but we will look at the examples that are covering different parts of the globe, and they were actually used as kind of models to look up to and to model our composition of drought monitoring systems. So the first one is US Drought Monitor. This is actually one of the oldest drought monitoring systems. The online version was available to broader public already in the 1990s, so more than 20 years ago. I would say that the general composition of this system is very friendly to the user. So when you enter, when you visit this web page where this US Drought Monitor is available on, you immediately see the map that is composed simply from the 5 drought categories, namely from zero, or I would say abnormally dry but not yet drought. That means that there is already noted a deficit in precipitation, but still no drought impacts are expected, through 1, 2 and up until D4. That means exceptional drought and devastating impacts. Of course, at the first glance, this might seem to be oversimplified, but as you will see later in the next slides, it can be very informative. One additional property that I would like to mention is that short-term and long-term droughts are separated here. That means that droughts that are occurring due to short, of course, short, it means short in terms of development of droughts. That means few months, as you can see, up to 6 months. You might remember from the second video that we were thinking or that we decided to use 60 days or 2 months as a kind of fastest time range to follow or to establish drought impacts. So in the time range somewhere between 2 and 6 months is short-term time scale for droughts, and the impacts here are expected mainly in agriculture and of course grasslands, so important for grazing farm practices. And what is also important, if you depend on a certain quantities or availability of fresh waters, of course the groundwater levels and so on depend mainly on the deviations that are much longer than just a few months. So in that case, long-term impacts that are typically greater than 6 months, it can be even years and so on, they reflect in impacts mainly in hydrological cycle, in groundwater levels and so on, and also in ecology. So as I said, at the first glance it seems that it's a very simple map. However, it was intentionally done so that all possible drought indices and indicators, as you can see them here listed on the columns, are blended into one combined drought scale. So as you can see, here is the standard precipitation index that you already know, the soil moisture anomaly, and the Palmer Drought Severity Index, which is somehow connected to the surface water balance. So a bit more complex, but it's similar to water balance anomaly. And this kind of indicator blend is used as for preparation of draft map, so the first version of the map. But after the preparation of the draft version, there is intense involvement of stakeholders. So hundreds of cooperation organizations or the partners that wish to be involved in preparation of drought monitoring products, or even farmers and so on, are contacted, and they give their observation on how do they see matching between different drought levels and the impact that they are observing on the ground or in the vicinity of their location. So the final version of the map is actually basically in many cases also manually corrected, but it actually reflects the condition of the drought impacts on the ground. And this is a very valuable information. As you can recall from the previous videos, it is very important that you try to match drought monitoring outcomes, the information that are reflected by different levels of drought indices and indicators, and the impacts that are being caused by drought on the ground. The second example is from Europe. So the European Drought Observatory is prepared by JRC, by Joint Research Center, which is actually part of the European Commission. So this is actually a system that is not prepared or is not driven by stakeholders, by organizations connected to farmers, but it is rather, I would say, administrative or a system that is prepared by and for administration on governmental level. Drought is not specified in categories, it is rather just described by origin. So is it caused by soil moisture deficit, by vegetation stress, or is there actually a recovery already recorded? So all this is of course prepared similarly as in the American case. So there is different blend of different indicators, and this blend is then called combined drought indicator. So you can see how it is prepared here on the bottom table. So again, for the precipitation anomalies, there are some specific levels of standardized precipitation index. There is again soil moisture anomaly, similarly as in American case. Also here it is deduced from a model, from hydrological model. And there is also remote sensing. So similar as in case of DMCSEE, there is a remote sensing indicator, not a fraction of vegetation cover, but rather fraction of radiation available for photosynthesis, FAPAR. And all these indicators are, all these values are then blended into a single colored, so to say, drought intensity scale. What is different to the case of the American drought monitoring system is that there is no stakeholder involvement. Impact assessments are obtained by I would say general or more modeled assessment of forecasting the agricultural yield, and also partially by scanning some specific media records. So very similarly as you saw in the case of DMCSEE drought bulletin. Apart from the maps itself, there is also an analytical assessment, so-called drought report. So the different levels of this combined drought index are here explained more in details. However, as I said, a bit more extensive information on drought impacts are missing. So to conclude, basically all three parts of this presentation. So you are now familiar with DMCSEE operational products bulletin. You are now prepared also to be more involved into a drought watch platform, which will be presented in the next sessions. And you now also know what are the main ingredients that are essential for successful drought monitoring system. So first is, of course, appropriate set of indicators, appropriate levels of indicators. So this is also very important. You need to establish your own levels and your own, I would say, alert thresholds. And of course, what is very important is also linked to the impact. So this is emphasized throughout the whole this presentation. So I wish to thank you for attention here, and of course you are welcome to attend also the other DMCSEE sessions.